Okay, thank you so much. Welcome back everybody to Play Day. If you're just now joining us, my name is Laura Masterson. I'm the Community Manager here at Typesafe. Before I introduce our next speaker, I just wanted to go over a few things. It was mentioned that the call is being recorded and we're going to be posting it on our YouTube channel and website shortly. So look for those in a day or two. As well, I'm going to be manning the Q&A section, so if you have questions throughout the presentation, feel free to submit those, and I'll try to address things in real time, and if they are questions that I'll reserve for the speaker, we'll address those at the end. So with that, I'm going to hand things over to Christopher Hunt, who's a senior engineer here at Typesafe. He's going to be presenting about SBT, and he's also going to just give you a little brief overview of Typesafe if you're new to the company. Welcome, Christopher.
Thanks, Laura. Well, welcome everyone. Actually, it's 9 a.m. here in Australia, which is below Sydney. And so it's the start of our day, but I think for many of you, you've been around all day. So thanks for hanging around, particularly for European participants where I know it's certainly getting on to be quite late there. So it's really appreciated. So what I'm going to do now is just share my desktop. Hopefully all of this works. So maybe Laura, can you just confirm that you can now see my screen?
Yep, we can see your screen. It looks great.
Okay, great. So what I would like to talk about today is sbt-web and in the context of play. And then in particular, I want to talk about the anatomy of an sbt-web plugin. It's very important for us, that we get a community going around sbt-web. I mean, we certainly cannot do everything there. There's a lot of tools out there that could benefit from being integrated with the sbt-web platform. And of course, in the JS world, there's a new tool pretty much every week. I say that almost jokingly, but it's actually quite true. There are quite a lot of tools out there, of course. So without further ado, I'll go on to this. Oops, I'm going the wrong way in my slide presentation there. Let me just get that sorted. Okay, all right. So my name is Christopher Hunt. I've been with Typesafe for a couple of years now. I'm a committer on the Play team, and I also I have been around for about 30 years in computing. I even programmed in COBOL at one point, which might be funny for some of you. Some of you might not even know what COBOL is, but Java is the new COBOL for a lot of people as well. Before Typesafe, I also worked at SpringSource and a few places before that as well. And I've been involved in Maven tooling for JavaScript. So this has been quite fun for me. The last 9 months in terms of developing sbt-web has been my second opportunity to do this, and I'm really very, very pleased, with the result that we as a team have been able to reach, to get. I also have done a few things. I'm the committer on the WebJars project, and as I said earlier, I live in Australia, in a place called Bulli, which is about 50 miles south of Sydney, 80 kilometres south of Sydney. I live by the beach, and in fact, I just got I kid you not, there is the office by the pool. So that's how we do it around here. It's actually winter for us at the moment, but I can tell you it actually looks pretty much like that even today. So I work for a company called Typesafe. Some of you may already be familiar with Typesafe. Our mission, if you like, is to become the enabler of the best reactive applications on the JVM. We're the caretakers of Scala, Akka, and Play. And our founders are Martin Odersky, who created Scala, and Jonas Bonnier, who created Akka. And we provide support, consulting, and training, of course, around Typesafe. Typesafe's an interesting company geographically as well. We're about 60 odd people now, I think. and we are based primarily in San Francisco, then in Lausanne in Switzerland, and Uppsala in Sweden. And then there's 4 of us in the Australia and New Zealand region, 2 here in Australia and 2 in New Zealand. And the 4 of us in the ANZ are full-time on Play. So you could say that Play is very much an Australian affair. Now, something is going on wrong with my slides here, so let me just get that sorted. Okay, so with Play, our goal with Play is to make it the #1 choice for web development on the JVM. But of course, with Play, it's very difficult to avoid the other technologies that appear at the front end there, particularly such as JavaScript and CSS. And so what we also wanted to do was to make Play a great choice for JavaScript development as well. So I want to be very clear here and state that we're not out here necessarily to compete with the Grunt.js of the world or the Gulps or whatever like that, but we want to be good enough, at least in terms of performance, for example, which seems to be the #1 reason. We want to be good enough so that you don't have to jump out of the context of Play and its SBT heritage, just so that you can prepare your assets for delivery from a Play server itself. So that's what our thinking behind that actually is. So we want to be as good as Grunt.js. That was kind of the mission sort of when we started out. Play also had a number of facilities already for preparing assets. It used to have the Google Closure compiler in there for asset minification and for verifying your JavaScript code. We used to have the less CSS compiler, and we also have required JS optimization. And all of these things were inbuilt. They were tightly coupled with Play Core itself. So, of course, as I alluded to earlier, there are many, many more tools out there than just less and required JS and Closure, and we found ourselves a little bit hampered. So our real motivation here was to factor out these concerns so that Play itself cared about one thing, which was just this notion of an asset pipeline, in effect, produced by a set of SBT plugins. And so that was the motivation, and by doing this, we've achieved a few things. One, we're less opinionated, of course, in terms of the tooling, right? And in fact, what we're going to be doing in a second is looking at a stylus plugin. We're going to go through the process of creating that stylus plugin. So I created that stylus plugin pretty much 2 days ago, and it took me about a day. And it was really mostly learning about stylus, So there already is something that's different to what we had with Play 2.2 and before, in that we were all about less, but now we know we can be equal on equal terms with stylus as well. So that was really important. We also wanted to be fully featured. So in our implementation of the less compiler last time, it was a pure Rhino-based implementation. And it was difficult, of course, to keep up with the new revisions of less as they were produced, because they're produced quite frequently, and we found that very difficult to keep up with. We also wanted native performance as well. So you'll see that with sbt-web, you can run either in JVM on a platform that's known as Trireme, which is basically a Node API on top of Rhino, or you can actually invoke Node directly for the purposes of these build steps. So they're the motivations. And in terms of Activator, we again wanted to fulfill its goal there of being, just a one thing you have to download and then you can get going with as soon as possible. So that's why the in-JVM requirement was really strong for us. Of course, that's good for continuous integration on some platforms as well. We also were motivated. We want to, embrace tools down the track as well, in terms of Grunt.js and Gulp, with their, massive communities around them. So we're certainly not excluding bringing those into the fold here at all. So I'm just going to quickly talk about WebJars, because of course this is all relevant to the Anatomy of an sbt-web plugin as well. So WebJars, for those of you who don't know, are merely they're regular Java jars, which of course are zip files, and we have laid these out. In fact, this is produced originally from James Wood, who used to work for us. And so these jars merely encapsulate web assets instead of just Java classes. And it lays them out in a particular directory structure within a jar itself. And why did we do this? Why did we sort of adopt this in a big way? And it's really because we find that with a lot of our customers, particularly in large enterprise, they've already got a lot of IT infrastructure in place, of course. They may have Artifactory installed or Nexus, for proxying various Maven and Ivy repos around the planet. And so there's a lot of infrastructure there to sort of leverage. And Maven, for example, in 2012 had 8 billion downloads, and in 2013 I think there were 11 billion. So it's actually not going down; it's actually going up. Also, these repositories, they're familiar, as I said, to these IT organizations. So that's a big driving factor here. And of course, there's a lot of tools and technology around resolving transitive dependencies and doing that general dependency resolution thing, which on the surface seems quite easy, but it's not so straightforward until you try and actually do it. So we wanted to leverage all of those existing mechanisms, particularly those mechanisms within SBT itself. So WebJars is about, well, it's a year and a half old now or so. I think it's got about 250 libraries in there. Certainly not anywhere near as much as what you can find in Bower, which I think is about 8,000, and NPM, and I don't know what NPM is up to. But certainly, there's a lot in there, and probably more than enough, to create some first-class applications. And if it's not in there, then the process of getting a WebJar in there is not so hard either. And that's something I think that we can work on further to make even easier. So that's the motivation there behind WebJars. What we do in terms of sbt-web is that we take a WebJar and we extract it out onto disk. So it's almost the same experience for you as a web developer putting these into your public folder. Download jQuery, extract it into your public folder under a lib jQuery folder, for example. Then, from your point of view, that is directly equivalent to adding a WebJar dependency in the context of sbt-web. So, sbt-web is built on SBT, and it's really just all about, just in some ways, Play extends SBT, of course, and sbt-web does the same. In fact, if you like, it sits in the middle and brings web concerns into the world of SBT. It's actually entirely independent of Play, although I need to emphasize here, Play was the #1 customer, the #1 driver for us actually doing this, but we were able to develop it in a way that it is entirely decoupled, and so you don't even have to use it in the context of Play, which we think is a nice. We did that mainly for architectural reasons more than anything else. There was no other strong reason for doing that. It's entirely reactive under the hood. We use a lot of Akka to manage particularly those mutable concerns in this world, like, for example, kicking off processes and managing their standard I/O and that kind of stuff. It brings an asset pipeline. We have this notion of source tasks and pipeline tasks. Pretty much it's down to those two things. And source tasks, in fact, are what we're going to be talking about a lot today, where you can also look at a source task as being the initial stage of an asset pipeline. It's the stuff where, for example, a CoffeeScript compiler would be a source task, in that you're taking Coffee files and then transpiling those into JS, and then once they're available in JS, they can become available to this linear pipeline where you can then perform other operations on there, such as minification and MD5 hashing and that kind of stuff. So that's broadly those two types of plugin that we're actually looking at. Pipeline tasks are actually really quite simple to write. Source tasks tend to be a little bit more involved. There's a bit more going on there, and that's why I'll be showing you how to do that one today. So if you can master a source task, then you'll kill a pipeline task, no problem at all. As I said, we do WebJar extraction, and we actually do something particularly interesting in terms of handling node modules. So WebJars that contain a package.json in there are actually treated slightly differently. And what actually occurs there is they're extracted to disk, and then the node path for node and for trireme is set up so that you can simply require these things quite simply within your JavaScript code. We provide facilities for incremental execution, and this is I think this is a really important one. We've noticed that with a lot of tools, I think this is the case with Grunt at least, there is no notion of incremental execution. It basically, if you've got 60 less files, it's going to do all 60 of them every single time that you execute that task. If someone wants to correct me, then please go ahead. But we provide facilities here for incremental execution, so that we only pass files to whatever compiler you're using, that actually have changed. And that we also manage things around dependencies as well. So for less, for example, you can import other less files, and so if the file that's imported actually changes, then it will ensure that the parent is then subsequently compiled again as well. So we've gone, I think, to a decent level there, and of course that yields performance benefits when it comes to building overall. In terms of reporting as well, we leverage SBT reporting infrastructure so that one thing that I've learned that people really like about Play is that the errors are nicely reported and formatted in the browser, and Play understands SBT compilation errors, and so what we do is make sure that sbt-web also renders those same SBT compilation errors as well, so you get that same experience even compiling a JavaScript program or whatever it might be, Scholar.js or ES6 or whatever. And so let me move on that slide there. This is the structure of an sbt-web directory. It's a little bit out of date. It's a bit of an old slide. I kind of forgot to update it. But broadly, you've got an SBT, of course, and this is not necessarily place structure, but in a regular SBT world, you've got source main assets, source main Scala, source main Java, etc. So we here have source main assets, source main public. Play, of course, is very similar. You've got, instead of source main, you've simply got app. And what's the distinction here between assets and public is that both are intended to be served by the asset controller, all right, by a web server, in effect. But assets are up for processing, in effect, whereas anything that's in public is just determined to be static, okay, and they won't get processed and that's in the context of a source file plugin. These things get merged if they end up in your target. I think it's target web main public now. Can't remember off the top of my head. And they all come together though in this folder, and then they, as a consequence, of having also gone through the asset pipeline. So your static assets are also subject to asset pipeline processing, such as minification and digests and things like that. So in terms of sbt-web structure, you've broadly got WebDriver and you've got JS Engine. And I won't talk about WebDriver too much, other than WebDriver is a protocol that's pushed now by the W3C. There's a WebDriver specification. We took the protocol and re-implemented it so that for those times when you actually need a DOM, right, in your plugin for some reason, then you can do so through WebDriver. And most browsers support provide WebDriver server capabilities. Interestingly, we started with WebDriver here, and we have not actually used it once because everything seems to be using this baby, JS Engine. And JS Engine is for those situations where you don't need a DOM. And it's kind of interesting, because I always thought this, but you hardly ever need a DOM, even for testing as well, unless of course you get into the realm of functional testing and those smoke style tests and stuff. But certainly for unit testing, you don't need JS Engine. For source file compilation, you tend not to use, need a DOM. And so everything that we've written so far uses JS Engine. So again, that's what we're focusing on today a little bit. For in-JVM support, as I mentioned earlier, we support something named Trireme, which is provided by Apogee, you may have heard of as a company, and they needed a Node API, an in-JVM Node API within their infrastructure. So it's highly evolved. We can even execute NPM in the JVM itself, which is a great test for it. It's not perfect by all means, and of course it doesn't have the performance of Node, but it gets you that in JVM experience. And then at the flick of a switch, you can use Node as well. So you can specify what engine that you want, either through an SBT property, or you can specify it through an environment variable as well. So you can have it for all SBT-web sort of concerns. And again, we sit squarely there on top of Akka itself. We did go down a common JS path initially, but what we learned was that the Node API, notice the emphasis on API, seems to have won. In that space. In terms of if you're looking for standards, then everyone seems to be looking towards the Node API. In Java 8, Nashorn have another project on the side that again is implementing the Node API as well for Java 8 on top of Nashorn. So at this point then, what I'm going to do is I'm going to show you this little program here. So as I mentioned, on Monday, I wrote the stylus plugin, and I did so because playframework.com and typesafe.com actually both use the stylus compiler. And so we needed it, and we had some requests from the community to provide one as well. And of course, I had to give this talk, and then I thought, well, why don't I try and write the stylus plugin? I'll say it from where you'll spend most of your time in writing an SBT-web plugin is in understanding the thing that you're trying to wrap itself. And that was certainly the case for stylus also. These things are not straightforward, right? So I'm just trying to set the right expectation there. It will take you 1 or 2 days to get a plugin up and going. But then this is no different, in my opinion, to how it would be in the Gulp or the Grunt JS world either. You've still got to understand this thing that you're actually wrapping. It's just, of course, in those worlds, it's more likely that someone else has already done that for you. But we do go a little bit further here than what I've personally seen in the gulp and grunt world. As I alluded to earlier, we embrace incremental execution for a start. And then also the reporting of errors is something we go a little bit further with. I was looking at the gulp plugin for Stylus, to gain inspiration for this. And basically, in terms of error reporting, for example, it just logs whatever the Stylus compiler logs to standard error. It just logs as well. So we go a little bit further. We actually parse that information so that we can provide SBT with the structured data it needs, such as the line number, the column offset, and the actual messages, so it can put a caret indicator in the right place and do all of that. So we certainly have gone a bit further. But what we're looking at here then is the project. So Laura, can you confirm this is all quite visible?
Yes, it is visible. Yep.
Okay. Readable is what I actually meant to ask.
It's readable if you go into full screen. And you can see it in the box as well, but I think it's much better if you go into full screen.
Okay. Well, so I can't go into full screen on this screen, so I just want to make sure that...
Yeah, I just meant for people watching.
I see. Okay. All right. Well, in that time, I'm sure you've all now gone full screen. So what we have here, it might be a little bit difficult to discern, but on the left-hand side, we have an SBT stylus project. But in fact, there is nothing SBT about this project at this point in time at all, right? What you see here in front of you is a pure Node, just a pure Node project, really. So we have a shell script, I call it a shell script. It's a JavaScript program which is going to wrap the Stylus plugin itself, the Stylus compiler. We have a style sheet for Stylus here, and we've said here we're going to require reset.style. And if we look at reset.style, then that's all it is, right? And then I've got a few auxiliary files, a README and a license. Ignore the lib file, that means nothing at this point. All right, so let's just focus on this for a second. One of the first things, so as I said, this is pure Node API, okay? And there's this little project here that of particular interest, which you may have seen the other libraries that are being required, but JS Transpiler is probably something you haven't seen, and the reason for that is because I invented it last week. JS Transpiler provides just this convenient framework to write transpilers in. And what it does is parse your process arguments. So it expects, it dictates a convention for parsing arguments to these things. So for example, I'll elaborate on that. It expects an array of source files to work on, and a target folder, and then a means to convey options in JSON form to this. And that is it. And if you omit some of those arguments, then it takes some of those defaults. And the reason I wrote that was because I found that with these source file plugins, there was a lot of boilerplate being written across each of them. And so I wanted to generalize that. But by the same token, you could actually use this outside of the context of an sbt-web plugin. You could use it more generally for simply writing any Node-based command that you want to. So before I take you through the structure, I'll show you that in working. I'll just increase the size of the screen here. So here's a command, right? We're going to say node. We're going to invoke stylus shell.js, which is what we were just looking at. And as an argument, we're just going to give it a.style. Now, when I press enter, I will return. it will fail. All right, so I'm just letting you know here that we're not suffering from demo blues. The reason for that is because we haven't downloaded any Node modules. Now, I could have pre-canned this demo a little bit, but I kind of wanted you to take you through the process. So again, just to step back a little bit, when we're writing these transpilers, I've seen out there in the community so far that there's this tendency to want to write the SBT side of things first, but really you focus entirely on the Node side of things first, and then we're going to wrap the SBT concerns around that. Okay, so that's why I want to sort of take you through this process. So I'm going to install JS transpiler, and then we're going to run it again. Oops, not that. And it's going to say it needs when. Okay, so let's go npm install when. And this is basically how you do things. And we need make.dirp, so oops, node install make.dirp. And, oh, didn't like that one, npm install, how about that? npm install. Okay, and then we'll run it again. And we need stylus. I tell you what, you know, whoever thinks that downloading the internet requires Maven or SBT should have a look at this world as well. Okay, npm install stylus. Okay, and we're going to get a few things there as well. Okay. All right, so now we're in business. I'll just run that again. Okay, so what we actually have here, in fact, I've got that thing in the way there, is it probably doesn't make a lot of sense at this point, right? But we've got this JSON structure that is sent to standard out, and it's sent in a way that we want to consume it in sbt-web. All right, so that's the idea. You can override that. You can make it do whatever you want, but that's its default behavior. And the direct equivalent of doing the above is, oops, if I go stylus a.styl, right? Oops. Oh, sorry. It's node that you love live things. Bin stylus a.styl, right? Then it just tells us that we compile the a.css as well. Now, by default, things will get written to the lib folder, so you'll see that we have an a.css. So just to show you that we're not cheating here, I'm going to remove that file, and I'm going to invoke our script again. And now, if you have a look in lib a.css, you'll see the transpiled form of that. All right. And so, just to show you what that's what it originally looked like, and of course, reset.style as well. Okay. So let's then have a look at our program that actually does this. And, incidentally, once you get this right, once you get that node command line working, then really the rest of it, wrapping the SBT stuff, isn't hard at all. And now I say that also, of course, with Grunt, SBT, Maven, Gradle, whatever, there is always, some learning curve, in the sense that you have to learn about their environment, right? It's never that straightforward to write a plugin, and SBT, of course, can seem a little bit foreign, but it pays off. Is all I can say. So in essence, what we're actually doing here is, actually, let's have a look at this. I'm using Kujos when, basically, to provide an implementation of the promise A spec. And when we invoke a processor, so it's all about writing this thing called a processor, we expect the return value of that to be a promise. itself. Okay, so in Scala terms, it's the same as the Scala future, right? But in JavaScript, it combines both the notion of promise and future together. What we're actually doing here is using the when library to lift an existing node function such that it returns a promise. So when you use refile, for example, in Node, you normally pass in a callback to it. And this function, node.fn, actually knows about that. The Node API has a convention in terms of its function signatures. And so it looks for those callbacks and lifts it in such a way that it can be used as a promise. So it's really pretty cool. And the reason that I did this was because what we actually have to do is we have to read the file, then we have to process the file, and then by calling stylus or whatever, and then we have to make the directories in the full path up to where we want to write the file, and then we have to write the file. And in Node, you can do all of that in using blocking calls, but of course we're reactive. We don't like to do blocking calls. But instead, what we do is we use these promises as well. Otherwise, what you do, you just get callback hell, right? And you get severely indented file. And that, in fact, that's what I did here initially. I wrote it as callbacks. I probably should have kept that as a comparison, but I didn't. So that's what's going on there. And then JST is you can see it's defined up here. It's JS transpiler. I just didn't want to write JS transpiler each time, so I call it JST. And what I'm doing there is just processing. Process.argv is just give me those arguments passed to Node, and JST.args will basically parse those. So as I say, the first argument it always expects to be that sequence of files, but it does stuff like if you don't pass a sequence, if you just pass one, then it builds that sequence for you. And the second parameter is the target folder. If you don't provide that, it assumes lib. And the third one is options, which is a JSON structure. So if you don't provide that, it just gives an empty structure, and that's excuse me, what it does. So the beef of the plugin here is what I'm actually now selecting. Okay, this thing here, this processor. So the processor takes an input file. So that's the path to the input file, and that's the path to the output file. And so we excuse me, are reading that file, and then with the contents that are passed to us, excuse me, we are taking its options. We're setting those options up for, excuse me, in this case, stylus. It requires a file name for improved error reporting. And then here is actually where we call upon stylus, with those contents and with those options. And then we ask stylus to render a file. But this is all very stylus specific. Less is quite similar. But of course, depending on your plugin, things will always change. What we're actually doing here is that once things are rendered, we either get an error or we actually get the CSS itself, that it produces. If we get an error, then what we want to do here is parse it. Okay, so from a processor, we are looking for a promise of either a problem type of object or what we call a result, okay, which is a successful result. And so what parse error will actually do then is take the input, the contents of the file, the error, use those things. In fact, I can show you just down here. It's just this messy little function to go and do some horrible string manipulation. Unfortunately, stylus doesn't provide a structured form of this information, whereas some do, some don't. All right, so sometimes you have to do a little bit of extra work there. In the case of success, then what we're doing here is just passing back this result. We're actually passing the contents of the CSS, and we actually also want to pass our style object back as well. That's for our I'll come back to why we're doing that in a minute. What we could just pass back is the CSS. Once we've read it, we could just pass the CSS back. But we actually need this style object a little bit later, and I'll show you why. So when that completes, and of course, if there is an error, we actually throw it. And just as with Scala, if you throw an error itself, so then these statements are equivalent to your maps. Okay, so they don't get called in the case of error. It's only in the successful state that you come through to these next ones. So it gives you a very clean way of programming, something that's asynchronous, of course. So what we do here is we make the IRP to make sure that our output paths are all constructed, and then once we've done that, we yield a promise of the result as well. All right. So this is all. There's nothing particularly fancy going on here. This is the QGIS when promise A API. So it's all consistent with that. So if you are a JS dev, this should all look quite familiar. If you're not, then well, it should still resonate, because there's a lot of similarity here with map and flat map in particular with Scala Futures. And then what we do here is we write our file, and if on success, we'll again yield that result that we have. And then finally, what we do here is return result structure that we're expecting. So remember I said that we're either passing back a problem or we're going to pass back this result structure. And the result structure that we're looking for is the name of the input file that we're working on, and then we pass back the files that have been read and the files that have been written. And so the file read, they're arrays. The file read here is our input file, obviously, but we're also concatenating here, and this is why we pass this style object through. Stylus actually tells us what files it actually brought in, what were required or imported. And we can get hold of those as an array by calling that. And that's how we can do that fancy stuff around, if one of the dependencies is changed, then compile, the bigger thing kind of thing. All right, so that's what's going on there. And then finally, the last thing that we do here is we basically process it. And we're saying here, here's the processor, here's the input we're looking for .style files, and depending on whether we've got compression going on, we're going to produce a min CSS or a CSS. Okay, and that's it. So what I'm going to now do then is go to sbt stylus, and I'm going to check this and call clean. And hopefully this is all going to work for us. What we now have then is the SBT wrapping of that, right? So as I say, you get all of that working from a node point of view, and then we put it into SBT form. All right, so let's have a look at our build SBT file. There's a lot of standard, sort of stuff going on here in terms of if you write an SBT plugin, then you've always got to do this kind of stuff, But primarily, SBT plugin equals true is what we need to do. I'm going to jump into the source here as well. So under resources, you'll see that we have that same stylus shell that we were working on before, right? So it now lives in resources, and it's called stylus shell.js itself. And if we look at sbt stylus.scala, then this is what we have. This is what it takes to write an SBT plugin. So there's not much. There really isn't much that we have to actually surround this with at all. First of all, again, a lot of this, if you're familiar with writing SBT plugins, then this will look, hopefully quite simple. We declare a task so that when at the SBT console we type stylus, then it actually invokes the stylus compiler for us. And then for every option that we want to present, we define here as a setting key itself. All right, so we only, I think there are more options in stylus, but on Monday I thought, well, I'll just implement compress. There are probably more to be done. What we say here is that we require a plugin called sbt-js task, and the trigger for this plugin is that all requirements are met. Now, what that actually means, you can see here, this is a thing called an auto plugin, right? And this is a really new SBT 0.13.5 feature that was pretty much created for our needs here. Obviously, it goes beyond just our needs, but we drove a lot of the requirements here. What it means is that when you add enable plugins for your project in SBT, all you have to enable is sbt-web itself. And any other plugins that are added to your project that are triggered, that have the requirement on that through a chain. So sbt-js task requires sbt-js engine, which requires sbt-web. Then if all of those requirements are satisfied, this plugin becomes enabled as well. Right, so it really cuts down dramatically the amount of configuration a user has to do. So with SBT stylus, if you want to start using that in a Play project, and incidentally you can now because I actually released this as well, then all you have to do is do an add SBT plugin for sbt-stylus 1.0.0 in your plugins.sbt project for your Play project. And you don't have to. And if you're already, enabled sbt-web in your project, that's all you have to do. There's nothing else required other than, of course, creating your stylus file. So we're doing a little bit of extra work here in the plugin to make life really quite simple. And what we're saying here is auto import is whatever is in the scope of import, which are these keys. And that's why in a build SBT file, you can say stylus keys.stylus or stylus keys.compress. : false, for example, and that's why you don't have to import com typesafe sbt stylus dot whatever. That's how these auto imports actually work as well. Then we have one of the probably more challenging things to learn about SBT in general are this notion of scopes. So we have general scopes. We have scopes that apply to specific tasks. We have other types of configuration as well, such as compile and test. In the case of sbt-web, we also have assets and assets test, or test assets, sorry. What SBT allows for is a hierarchy of these things to be built up, so that if you don't have a setting, for example, defined for this task in a particular configuration, then it can actually look then just in that configuration and then into wider sort of scopes again. So it's good because, for example, a way that we use this is when you specify the JS engine that you want to use, whether you want to use Node or Trireme or whatever like that, you can specify it just as JS engine type equals whatever. Node, for example, and that applies to all plugins. Or you can do it. You can say JS engine type in stylus, for example, and it will just then set that engine type for this. So that's why we have these hierarchies. And so what's going on here is that we're actually just setting up those things, in certain scopes. Sorry,
Christopher, this is Laura. Yeah, I just wanted to interrupt here. We are going a little over time, and we still have one more webinar, so I don't know if you have a couple more things you want to go over before we end, but James Roper is going to present immediately after you.
Yeah, no worries. Do we have any burning questions at this point?
I think we're set to go on the Q&A section. I think what we might want to do is just have you follow up with any questions that people have submitted.
Yeah.
Great.
Yeah. All right. Okay. Well, all right. Well, I'll just I'll try and speed along a little bit more. Then sorry that I've run over a little bit here. So we're defining our settings here. What we're effectively saying is that by default, we're including anything called main.style. Just as per less, you have to actually list the files that you want to throw at the compiler. You can't just throw them all there. And we're here just converting an SBT setting into a JSON object and passing that to this thing called JS options, and that will automatically get presented then to the JS plugin. Other things of note here, the module name we're calling stylus. This is where we specify, the shell that we want to actually use, and these are simply the messages. And then these functions here just set up some of those scope things. So I'm rushing through it a little bit now. Under SBT stylus tester, what we have here is what we had before, our main style, our reset style. We have a build SBT, which is simply enabling sbt-web, and that's all that's to it. So this is quite a common layout for when writing a plugin. You have a tester, and it basically allows you to go into that folder, type SBT, and it will allow you to interactively test these things, which is what we're actually going to do right now. So while that's just downloading a couple of things, we'll go back up here. The other thing that you do quite typically is you define what we call scripted tests, which, here's an example of a scripted test. We set the engine type to node, for example. We invoke the assets task. The assets will run all the source file plugins for you and put them in the public folder. And then we assert that certain files exist. We're now testing compression. We'd run assets again. We're making sure that one no longer exists and this one exists. So scripted tests are, again, a common part of writing SBT plugins. So what I can do, I shouldn't need to do clean, but I will anyway. So I can produce these assets in a number of ways, but most commonly you type assets. And what it does there is it's going to now invoke the stylus compiler. Now, just so you know, the stylus compiler, actually we had difficulty making it run on trireme. I didn't have time to actually sort that out. But let me just get the configure. So you actually do have to do this. You have to set the engine type to node, just for now, until we get this problem sorted out. Okay, it's still an improvement. So that's how we change engine types. And now if I run that again, you'll see that it produced it. And if I, because we've produced it once, if I run it again, it doesn't invoke it the second time unless I do a clean. And then, of course, it's going to go and produce that. And just, again, so there are no smoke and mirrors going on, if we look in our target folder, under web, public, you'll see there's the CSS that actually got produced. So that is all that needs to be done in a nutshell. This particular project can be found at github.com, sbt stylus. Okay, and I made a 1.0.0 release of that yesterday. So you can start using that in your Play projects right away. So let me see if I had anything more on my slides there. I did have this slide. It's not important that you can actually read this, but on the right is all the configuration to set up Grunt.js so that it can use JS hint. And on the left is what you need in sbt-web. And in fact, actually, those last 3 lines have gone as well. So I hope you agree, that configuration, becomes quite simple. We talked about plugin anatomy. So in progress, what's done, we've got CoffeeScript, less, we've now got stylus. We were going to do Jasmine. We haven't done Jasmine. We did Mocha. Instead, we've got require.js optimization. We've got SBT Digest, which produces MD5s or SHA-1s of your files for use in asset fingerprinting. And we have gzip as well. So that's me. Thanks for listening.
All right.
And Laura, I think I'm on time actually.
Yes, thank you so much, Christopher. That was great. Unfortunately, no time for Q&A right now. We're going to hop off and do the next presentation with James Roper. But again, thank you so much, Christopher, and for everyone who tuned in. And for those that are joining the next session, I will see you on the other side. So talk to you soon.